Now we will discuss the problem related to Chebyshev filter. Now in this problem we have to design analog Chebyshev filter. The problem states that design analog Chebyshev that will pass all frequency greater than 200 radian per second with no more than 2 dB attenuation. What does it mean? It is given passband between frequency 200 radian per second and passband attenuation is 2 dB and has stopband attenuation of greater than 20 dB and all frequency less than equal to 100 dB. What does that mean? Here omega p is greater than omega s. If omega p is greater than omega s, what does that mean? It is high pass filter specification. Okay. Now, but as you know, uh, the Chebyshev or Butterworth filter only takes the low pass filter specification. So we need to convert this specification into low pass filter specification. So we will take del omega s as a del p and omega p as a del s. Means we will interchange this value. Now initially we need to find out the order of the filter of the Chebyshev filter. How do we calculate the order of the Chebyshev filter? First we need to calculate m value using this equation similar to Butterworth and omega value using this equation. Just consider here we are taking dash value means exchanged value. Now to calculate n value we need to take cos hyperbolic inverse of m upon the cos hyperbolic inverse of omega, that is 2.47. Now we need to round it off this value then integer because we need to make it integer, so n is equal to 3. The first step, that is we have calculated n is equal to 3, the order of the values. Now we need to calculate this epsilon value, that is 10 to the power 0.1 kp minus 1, that is 0.764. Second step is we need to find out the normalized Chebyshev low pass filter transfer function, that is HNS. How do we calculate HNS? HNS is equal to h upon ds. HNS is equal to h upon ds. First we need to calculate ds. How do we calculate ds? There are lots of steps which is going on, which is specified in the Chebyshev filter design step in the previous class. For that we need to calculate UK, V, U and P. What is P? P is the pole of that particular system. So calculate P, we need to calculate sigma k and omega k. To calculate omega k, we need to calculate cos omega k into cos hyperbolic V. Similarly, for calculating sigma k, that is minus sine of omega k into sine of hyperbolic V. Once you calculate all this value, you just put the value into the pk formula. You will get different poles over here, that is minus 0.14 plus something. This is you will get this value. Once you will get the values, once you get the value, you just put over here to calculate the ds. Once you put it over here, you will get ds value. Now we need to calculate one more thing, that is h value. How do we calculate h value? Just put s is equal to 0, so h naught 0 into d no d0 will be equal to h, and we know h naught 0, what is h naught 0? 1. Why? Because n is equal to n is odd, n is equal to 3 na? Then n is odd, so h naught 0 is equal to 1, and if you put s is equal to 0 over here, you will get d0 is equal to 0.326. Once you will put the value, you will get this value, h naught s upon s cube. This transfer function you will get. It is a normalized transfer function. Now the third and final step is that we need a frequency denormalization. Now we know we need to find out the high pass filter specification. So instead of s, we need to replace this s by omega p by s. Omega p we know is it's a 200. We need to take the original omega p upon s. Then you need to replace this value and you will get h of s.